Bismillah Rahman Rahim. So let us start our module 6. In this module, we will be talking about the checking of the model, which I have already explained in our previous modules, and then diaphragm assignments and the assignments of the structural members as per the code, and then we will be selection of the desired code and the analysis of the model and discussion on the results. So before assignment of the loads, there is a check that is needs to be done, which I have shown to you in the previous modules. And these checks are done for the joint connectivity issue, for the shell overlapping, frame connectivity issue. These are the different checks that software do when you apply that command. So before running the model, there should be no error, and you should check the model. So what will happen when there is an error? So it will show you a command window like this, give you warning that the model has been checked, and there is a warning that the F87 and F6 are too close. F means floor, and these are two overlapping. So for this type of error, you have to select that shell and delete and draw it again uh, with accuracy. Right, so we have checked that in our previous module, so don't need to waste our time on this. It's very easy. You can go to the tab in here, for example, click on the analyze and click on this check command, and then select all and click OK, because I'm not clicking on OK because it will take some time, and there should be no error. If there is an error, you have to remove that error. The next is the diaphragm assignments. The diaphragm must be assigned to the horizontal elements, that is the slabs, which is designed as a model as a shell element in order to transfer the seismic forces. The seismic forces coming from the design earthquake into the slabs, and then the slab will transfer it to the element, which is the beam and columns. As the slabs will not be designed for the earthquake axial forces, because it will transfer the load to the beams. So the beams and columns are actually the two structural members that resist the seismic forces, and the slabs are normally designed for the gravity loads. And there are two diaphragms. One is the rigid diaphragm, which is the concrete slabs and decks, which do not incorporate the effect of the shear deformation. And the next is the semi-rigid diaphragm, which can be used for the steel decks, for example, the steel bridges, wooden slabs, and the hollow slabs, which incorporate the shear deformation, which will give you the shear reinforcement as well. So we'll move towards the software, and we will select the slab properties and slab, which is the 6.5 inches, and click on the all story. Let's click this as well, and then go to the assign shell, and this is the diaphragm command. You can click. You can also define it from the define menu as well, but let me show you how you can define it. Click on the D1, click on the modify, and you can define your own diaphragm, whether it is rigid or semi-rigid. So if you check whether the D1 is rigid or semi-rigid, you can click on the modify, and you can see that the D1 is a rigid diaphragm. Click OK, OK, and now apply this rigid diaphragm to the slab, and you can see it will help the software to calculate the uh, stiffness, center of stiffness, which is also known as the rigidity, and the central center when the earthquake forces occurs, so it can incorporate the eccentricity effect in your building. So if I right click on the slab and click on the assignment tab, you can see that on the diaphragm, the D1 diaphragm has been assigned to the slab. And the next is the assignment of the loads to the structural members. The dead load is already, we have taken this modifier, the sulfate multiplier is 1, The next would be the SDL, which is the superimposed dead loads, and these loads are applied as per the requirement, as per the building function, whether it is hospital, it is a school, it's a apartments. We have to calculate the different SDL superimposed dead loads for that building. In this case, we will take the 30 PSF for 3 inch of the tiles on the floors, and for the calculation, we have to take the PCC plus the tile thicknesses. We will take is a 4 inches. Normally, this one is taken, but we will take as a 4 inches, and the density we will take as 120 PCF. The area load you can calculate by multiplying the density into the thickness, and you will get the 40 PSF load. And in addition to that, we will take 10 PSF load on all the floors to incorporate the load of the bricks or the formwork. So total 50 PSF of SDL load is to be used as SDL on the slabs. Next is the partition walls or the brick walls load. The partition walls are normally taken as the one kip per foot on the beams. And how do we calculate that? If the wall thickness is 9 inches and the density is 120 PCF, so the loads per foot can be calculated as the density into the thickness into the height, and you will get the 990 pounds, which is equal to 1,000 pounds, which is the one kip per foot. Now you should be able to calculate the loads for the any type of material, whether it is the concrete blocks, hollow blocks, solid blocks, whether it is 9 inches, 8 inches, 4 inches. You should be able to calculate the load per foot. So we'll go to the software, and we will select the slab. This is actually, we select this and assign the shell 6.5. Now select the slab, which is the slab properties, slab section 6.5, and go to the assign uh, shell loads and click on the uniform. And now you can see that the load patterns you have defined will appear in this drop down menu. We will select SDL, and the uniform load tab we will insert 50 PSF, which is pound per uh, square feet, and the direction should be in the direction. You can also select the other direction as per your requirement, but normally in the design these are for the different research purposes and for different structure. And for the normal design you have to take the gravity and click on apply, and this should be replace existing loads. If there are any existing loads, you can replace that, right? So if you want to add an additional load only to this panel, then you have to click on this add to the existing load, so it will become 50-50, it will become 100. You can see it will become 100 and the remaining will be 50. Let me undo this. So we have assigned the SDL load to the slab. Now we will assign load to the beams as well. We will go to the select object type and click on the beams. All the beams will be selected, and click on the assign uh, frame loads. Click on the distributed and assign the SDL as 1 kip per foot. But there are certain beams that has no bricks on it. You can see in here that this is the plane. There is no brickwork in here in these beams, small beams, in this corridor, in this white passage, and in this white passage there is no beams on these beams. So you have to deselect those beams and click on the delete the SDL loads that you have applied. So we will uncheck the floors, walls, and we will show the undeformed shape. We will select all stories. So these beams will be selected, and these beams will be selected, just like these beams. These are the beams, and these are the beams that do not carry any brick loads. I think this is also a passage, the middle one. So we'll select also this one and go to the assign frame loads distributed, and the SDL you have applied. Now you have to delete the existing loads. Click on this and click on apply. Now you can see that the loads on the other beams are here, but there is no load on this beam that you have deleted. If you right click on the beam and go to the load assign, the load pattern is SDL and the uniform force is 1 kip per foot. On the other beam, there is no load applied, right? So this is how you can apply the load on the beams and the on the slab. But there is also a question, if the walls are not resting directly on the beams, so what is the solution? So for the partition walls that are not resting on the beams directly, then area loads of the bricks should be applied on the slab. For this, you can calculate the area by multiplying the density with the height into thickness divided by the area of the slab. For in our case, there is a panel which I have included, that these are the walls of the washrooms which are not resting directly on the beam. So you have to calculate the total length of the walls. For example, this length, this, and this length, and you have to add all of the length of these walls, which comes out to be 104 feet. So you have to multiply the 104 feet uh, into the height, which is 11 feet. The thickness is 4.5 inches divided by 12 to convert into feet into the density. So the total weight is come out to be 51480 pounds. So then you have to multiply with the area, which is this panel. This is 12 plus 15, which is 27, and the next one is 19. It becomes, for example, if you take this from the center, it is 19, but if you go to the end, it will become 20. So we have to multiply with the 27 by 20 panel this total load. So it comes out to be 95 psf SDL load. So we will go to the, so these are the two panels, and this beam also carry no loads, right? No, this one, this one. So this beam also carry no loads. So we will select this beam, these two beams, and these beams in all stories, and we will go to the assign shell distributed load and delete the existing load. Now we'll uncheck the floors, and we will select, we will divide this shells into smaller shells. Now we will select this 12 into 12 by 15 into the 19, which becomes 20, and we will go to the assign shell loads uniform, and this time we will insert 95 pound per square foot, and will add additional to this 50 pound per, it will become total of 145 pound per square foot, right? So this is actually the method you can apply on the shell if the walls are not resting directly on the beams. Next is the assignment of the structure loads, which is the live loads. And for the live loads, you have to go to the table, which is the 5.1 uniform and concentrated loads, and these are the different categories given for the access floor system for the office, which is the PSF is 50. So we will take 50 PSF for the offices, and we will take 40 PSF live load on the shops, because it is mentioned in the ASC 7 documents. It has been categorized in the residentials, and for the residentials, the basic floor area is comes out to be 40 PSF. You can check out the live loads, for example, for the hospitals. For the wards rooms, it is 40, and for the libraries, reading rooms, it is 60, and so on. You can check the different categories. For the live loads, these has been selected from the ASC 716 table 4.3-1, that for the walkways and the elevated platforms, which is the ramps, the live load has to be taken as 60 PSF on the ramp, on the slab, or the raft on which the parking will be, or the cars will be moving. So we'll go to the software. Again, we will select the slab 6.5 inches, and we will assign the shell loads uniform. This time we will select the live load, and we will insert overall at first, for example, 40, right? And now we will go to the plan first. This, you can see the the parking load will be on the raft. We will take in the design of the raft, and the shops will be on the first slab, and on the second slab, the first floor, which is the slab of the ground floor, and next is the ground floor to top floor, it is the offices. So the first two slabs, for example, ground floor is actually the slab of the basement, and the first floor is actually the slab of the ground floor. So we will now select only these two. We'll uncheck the all stories, and we will click on these two stories, for example, story 1 and story 2. These values will be 40, and for the remaining offices, that will be 50. So again, we will select previous, and we will assign shell uniform, and we will make it 50, so it will become easy for us to select only two floors to insert the value for the 40 places. We'll select this one story, story 1, story 2, and story 1, and we will assign the live load of 40 for the shops and 50 for the offices. So these two floors, story 1 and story 2, you can see the live load is 40, and for the story 3 and to the top, it is 50 pound per square foot for the offices. The next one is the loads for the retaining walls. Normally, the retaining walls are designed on the separate models with the surcharge loads, because if you apply a live load or the SDL load in the same model, so it will incorporate with the calculation of the base shape. But for the understanding, we will take it in the same model. So these loads are applied as per the requirement, whether there are two basements or one basement. So for the calculations, we have the height of 11 feet, the density of the soil we will take as 120 PCF, and for the basic formula for this pressure, it is X plus By. I assume that you know all of these. And there is no load in the X and Y direction, so these two terms will become zero. So we are left with the P is equal to CZ plus Z, right? So this is the basic pressure distribution. The pressure will be zero at the top and will be maximum at the bottom of the raft. Let us assume that this is the wall of the this is the retaining wall, and this is the road level. So the pressure of the soil pressure will be zero at this, and the pressure will be high at this. So in the ETAB language, it takes Z as 0 at the maximum, at the point where the pressure is maximum, and it takes Z as 11 where the point P is 0. And then you have to apply the coefficients in the E tag as per the calculation. For example, when z is 0, and so this term will become 0, the p is 11, right? So the p 11 is multiplied with the 120, so it becomes 1330 psf. So if you put these values in the equation, so the equation will become d is equal to pressure, which is the 1320 psf at the base. So again, if you insert the values, for example, for the z is equal to 11, the p is 0, and again you have to insert the d value, the z11 and the p0. So the equation will become c is equal to minus 20 psf at the top. So these are the two coefficients that you have to insert these values in the E tab. Now we will go to the plane view of the story 1, and we will show off only the retaining walls, and we will click on the other object assignment, and we click on the local axis. The direction of the local 3 axis, which is the blue arrow, this should be towards the building, which means inside, because the pressure will be from the outside, so the direction should be towards the building. So you have to convert this direction. You have to select those areas, retaining wall, and you have to change the direction of these by going to the edit shell, and click on the reverse wall local 3 axis. So the direction of the wall's local 3 axis should be inside towards the building. Now select the retaining wall, which is the retaining wall 12 inches, and click on the assign shell loads, and click on the non-uniform, and click on the SDL. Uh, I have told you that the software will calculate the base shear based on the dead load in SDL. So it's better to take it as a live, but it also give you over reinforcement. So I have told you that these retaining walls are modeled or designed in a separate model. So this time we will take is as a live or dead. It's your choice. So we'll make it as a SDL because it is a superimposed dead load, and the direction should be local 3 axis because we have set the direction towards the building, and these are the coefficients a b c. A b are 0 and the c was 120 psf. You have to please keep in mind the units, and the d was 1320 pound per square foot, and click on apply. So this soil pressure has been applied on the wall as per the requirement. The same loading can be applied on the overhead water tank. Example, if you go to the top story, and we will select, this time we will select the those shells in which the direction of the local axis should be uh, outside, and this is outside as well. We'll go to the edit shell and reverse the local 3 axis. Now because the pressure is from inside to the outside of the walls, that is why we have converted these, and the pressure on this wall will be 0 because both tanks have the same dimension, and the water have the same density, so the pressure will cancel the effect of each other. So we do not have to apply the pressure on this wall. We will go to the assign shell loads non-uniform. So how much load is applied in here? Uh, we will calculate. The water loads will be applied on the water tank bottom as follow. The height is taken as 6 feet, and the density of the water is 62.4 pcf. If you calculate the load, that becomes 375 psf live load, and the load on the walls will not be considered because the seismic forces will be applied on the water tank as well, and it will cause many issues. because we do not want the retaining wall to act as a structural members, but to resist only the water, because the walls or the let me show you the. So you have to apply the loads as per the requirement which we have calculated, and then you have to save as the model, and then you have to delete all of the walls and columns. We have to just left the water tank, and then you have to calculate the reinforcement for the water tank as per the requirement. Let me show all of the columns and beams. You can see that there are the columns and beams. These are the columns and these are the beams that make the frame for the hair water tank. So these will be resisting the seismic forces, and it will give an additional help. But we do not want a complete system to be. Do not want the water tank to be a complete part of the structure resisting system, because if you take, you can do it as a case study. Because if you take the uh, load on the walls as a live load, it will cause many issues in the structural designing. So we will take the effect or the overall the gravity load of the water tank in order to calculate the seismic forces base shear based on the live loads. We'll go to the assign shell loads uniform, because on the bottom the pressure is uniform, and we'll click on the live, that actually is gravity, and how much is the load. It is 375 psf live load, that is 375 psf live load. So this was the whole story about the assigning the different loads to the structural members, and then you have to run the